Good morning. We are going to talk today about the characteristics of a quadratic function. So a quadratic function is a function that the highest power is 2. So if you guys recall from last unit, we did a lot of work with the function ax squared plus bx plus c when we were factoring. And we were using quadratic functions because our value, our highest exponent was 2. And a quadratic function, the graph of a quadratic function is forming a curve, as you can see on that graph there. And that curve we call a parabola. So a quadratic function graphs what we would call a parabola. So let's talk about just a couple of the characteristics of an actual parabola. So the first characteristic that we want to talk about is the vertex. If we think about a parabola, so it's either going to be opening up like that, or it's going to be basically a U that's opening down. And your vertex is going to be what we would call the highest or the lowest point, which would be those points right there. All vertices are some ordered pair x comma y. So it doesn't matter, they're going to be some ordered pair. So what's interesting about the vertex is it is the center. We know that the shape of a U is what we would call symmetrical. And it is symmetrical because it's the exact same thing on both sides if I were to draw this dotted line here. And that dotted line is called our axis of symmetry, which we will refer to as our AOS. Instead of having to write out all of the words of axis of symmetry, we'll just write AOS. That's that vertical line that is passing through the vertex that's cutting that U or that parabola in half. And when we think about the vertex and the ordered pair of the vertex is x comma y, our x value is the AOS. So the axis of symmetry is the x of the vertex. Now the other thing that I want to talk about is whether the graph is opening up or down. So if a graph opens up, then it's going to have an A value that is positive, and we would consider it to be a minimum. Now why would that be the case if it's opening up? Well, when we look at a graph and it's opening up like so, this vertex is the lowest point of the graph. Hence, that's why it is a minimum. So when A is positive, when we think about ax squared plus bx plus c, when A is positive, the graph is going to open up and it's going to have a minimum. When A is negative, the graph will open down and it'll have what we call a maximum. So why would it be a maximum? Well, when we look at a graph that opens down, the vertex is the highest point of the graph. And so that's why when it's opening down, you're going to have a maximum. Now when we think again about that ordered pair of your vertex, x comma y, this we said is our AOS, if you recall. This right here, our y value, is the minimum or the maximum, depending on if it's opening up or down. So, whoops, that's supposed to be an x. It's a minimum or a maximum, depending on whether or not it's opening up or down. And we can determine the up or down just by looking at the A value. So let's look at a couple problems. If we were to look at, move this over a little bit, let's look at number 1. So we have to be in the form y equals ax squared plus bx plus c. And if we're in that form, then we can determine whether or not we are opening up or down. So on number 1, we are going to have to get y by itself before we can actually determine this. So to get y by itself, we would have to add 5x squared to the other side. And then when we rewrite that, we have y equals, in standard form, it must always be in standard form, we would have 5x squared plus 2x minus 6. So then what we do is we look at our A value, which is 5. 5 is positive, so since 5 is positive, then we are going to open up, which means our graph will look like this, and we're going to have a minimum. So number 1, would be up and a minimum. If we look at number 3, f of x really just means y, and it's already in standard form. So we look, and here is our a value. It's -4. So because it's negative for number 3, we would say it opens down and it has a maximum, because if it opens down, it's going to look like that. Okay, let's look at some problems to determine the vertex axis of symmetry and whether or not it's opening up or down. So let me move some of this for a second so that we can see it a little bit. So I'm not going to do all of this because I haven't talked about all of it yet. So we're just going to look at the graph number 1. This particular graph, it is opening up. So we're going to say it opens up, and because it's opening up, I have a minimum. Our vertex is going to be that point right there, and we would have an axis of symmetry would be that dotted line. That's what's cutting that U in half. So our vertex, if we count, that's going to be at the point -3, 2. So there's our vertex. Our axis of symmetry, if you remember, our axis of symmetry is this x value. So our AOS is going to be x equals -3. And then because we said it had a minimum, our minimum value, if you recall, is going to be our y value. So our min, so min goes with the green there, is going to be at 2. So your minimum is at 2, your axis of symmetry is x equals -3, and your vertex is at -3, 2. So let's look at graph number 2, and let's do the same thing. So let me erase this. If we look at graph 2 is opening down. So it's opening down, which means I have a high point, which means I'm going to have a maximum. The vertex is going to be that ordered pair right there, and then our axis of symmetry is that line that goes through the vertex. So if we count, our vertex is at 2, 5. And if you remember, our axis of symmetry is the x of the vertex. So our axis of symmetry is at x equal 2. And then our max is the y of the vertex, which means our max is going to be at 5. So we use our vertex to